Hello, everyone, and welcome back. This is 3.1 Kinetic Energy. I'm Mr. I, and I will be guiding you through this. This one's actually going to be a real easy one. There's not a lot here. This is just an introductory into energy, and they're going to start with the first one, which is kinetic energy. So, real quick, let's go through this. And the first things first, learning objectives for this one are describing the translational kinetic energy of an object in terms of its mass and velocity, understanding that translational kinetic energy is a scalar quantity, and then explaining how different observers may measure different kinetic energy values based on their frames of reference. So let's go ahead and get right into this. Kinetic energy, and what is it? Kinetic energy is energy in motion. So anytime you see, I mean, right now you see this person here, she's sitting still. If she's sitting on the floor, there's no energy here. She's just sitting there like a lump. Now, the minute you move her, kinetic energy is involved. Okay, so really pretty simple. Okay, it's energy in motion. It's also a scalar. Now, what does that mean? Okay, look, kinetic energy has to do with velocity, and we know velocity is a vector. We also know that velocity is dependent upon displacement, and displacement is a vector. So it should be a vector, right? No. Kinetic energy is a scalar quantity. It's just there. There's no direction to it. You either have kinetic energy or you don't have kinetic energy, but there is no direction associated with it. And then finally, we have it's frame dependent. Okay, what does frame dependent mean? Frame dependent means that basically we can isolate a system. Okay, so when we're dealing with this, what we're talking about here is you can see this little kid's in a box and he can't get out. But basically what this means is if I want to talk about the energy in a system, and we're going to talk a lot about this in the conservation of energy section later on, but basically what's going to happen is you have this particular individual right here who is in this little box. And so all of the energy in this particular system is contained. Anything that's happening outside of this box is a different system. So if an observer is on the outside looking in, they may actually see something different than the person that's actually inside the box. That's what it means by frame dependent. So when you're getting questions in AP, a lot of things that you're going to see is you're going to look at this and you're going to say, oh, okay, that seems simple enough. And then you get it wrong. And you're like, why? And the reason is because they talked about the actual frame that everything is in. You'll see something like the Earth-Man system or something like that. That is telling you what's inside the frame. And you've got to pay attention to that. Okay? And I believe that when you get into energy, it's the first time they really start talking about those kind of things. This is a little different than the relative motion and the relative frames. This one, we're talking about determining what's all in there. I guess we sort of did that when we did our calculations. Okay. The next thing, there are two types of kinetic energy. The first one is called translational. The second one is called rotational. Now, this is really simple. Translational is moving in a straight line. Okay, it's just moving in a straight line. It's linear. That's what translational means. It's linear. Translational, tangential, whatever you want to call it. Rotational, well, it rotates. And we're going to talk about rotational kinetic energy much later on. That's going to be Unit 5. That's in the second semester. So let's just right now forget about it. Let's just skip it. All we're going to talk about today is translational kinetic energy. All righty. So let's take a look at this. Energy in motion. What does that mean? Basically, energy is dependent on mass and velocity. All right. When we look at it, mass is directly related. So if I increase the mass by 2, kinetic energy is increased by 2. However, velocity is exponentially related. And this is really, really important. And we're going to get into this in a second. But basically, velocity is squared in this system. Okay. So if I increase my velocity by 2, the kinetic energy is increased by a factor of 4. Okay. So keep that in mind as we go through this, because what we're going to talk about right now is the equation. And the equation is K, or kinetic energy, is 1/2 mv squared. And right there you can see what the three values are. Kinetic energy is in joules. The unit of measurement for energy is joules. That's Joules. It's a capital J right there. Mass is in kilograms and velocity is in meters per second. And it's really important to remember, and I cannot stress this enough, when you're on a test, you're rushing and you stop, you're not looking at it properly. There are two key points here that most every student messes up, okay? And that's the first one, not squaring the velocity. I will tell you on a multiple choice test, the multiple choice answers, one will be with squares, the other one will not. The other big one, everybody forgets the 1/2. All right. The 1/2 there is also very important. So keep that in mind. You'll have four answers on a multiple choice. One will be with a square, one will be without, one will be with 1/2, one will be without. So keep that in mind. That's how they're going to do this on AP. They really want you to understand that kinetic energy, translational kinetic energy, is 1/2 mv squared. And that'll do it. I'm Mr. I, and we shall talk again. Take care, everyone.